going to be 4 b squared was good, plus 4b squared. And since this is my Jacobian, that junk is going to go right there. Look at the bound. How do you feel about the bound? You should feel fantastic about the bound. Those are awesome, right? I can go from 0 to 1 all day long. The whole point of transformations is to clean up the bounds and make it easier to plug in things. That's why we went from rectangular to polar before, rectangular to cylindrical, rectangular to spherical, to make everything nicer for us. Now, the big problem here is that we were given this transformation, right? And in reality, no one's going to tell you how to transform your function. You're going to have to figure it out. So what we're going to look at now is an example where the transformation isn't given. That is, we just know we need to find one. We know we need to make our lives easier. So, we're going to call it figuring out the transformation. To do it, we need to look at something that looks disgusting, scary enough that we're willing to even try transforming it. So we're going to look at the double integral over R of e to x plus y divided by x minus y dA. I'll do this our bounds in a second. The first thing I want to do is talk about why this is awful. Are you going to be able to integrate this nicely? No, right? It's going to be pretty freaking awful. Which means, in reality, we're going to run into all kinds of problems. We want to transform it to make it easier. The whole goal is to simplify. Which means that basically what we're going to do here is we're going to try and figure out an easy transformation over. That's something that's really, really, really nice to deal with. Well, I have two different things here, right? I need to figure out what U is and what V is. Well, what would be something really convenient for U to be? Why not? I get to choose what the transformation is, so that'll make my life really, 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 really easy, right? Now here's the problem though. When I write my transformations, I don't want to write it as U equals this and U equals this and V equals this. I'm going to need to solve for X and Y, right? So I can visualize everything and then transform it over. Really quickly though, just to give you an idea of what we're going to get into next time. So we'll take the next minute to go ahead and do that. So what we want to do is we want to isolate X and Y. That is, express X as a function of U and V and Y as a function of U and V. Let's look at the first one. Which one do we want to isolate? It doesn't matter. You guys can choose. X or Y. X. Well, if I try and isolate X, I'll get U minus Y equals X, right? What could I do then? I could plug into X for the second one, right? Then I'm trying to get X equals something, Y equals something like we were given in the last one. So what I'm going to do now that I've isolated, I'm going to plug in. That is, V is equal to U minus Y minus Y. Looks good? Okay, can I drop my parentheses? Why is X not? U minus 2Y, right? Can I solve this for Y? Okay. I'm going to go ahead and swap the U over. And then what? Divide by -2, right? That's the same as multiplying by 1/2 and I'm going to distribute the negative in. We would then do exactly the same thing in order to get what x is going to be equal to. In your homework will guide you through all of this, and this is kind of what I expected to happen. I expected to get a little bit further, but not much.